They called it a stupid rubber trick, a laughable fix that no serious aeronautical engineer would waste time on. Yet this dismissed innovation transformed the Republic P-47 Thunderbolt from a sluggish giant into a rolling predator that could outmaneuver the legendary Messerschmitt Bf-109 in the one axis that mattered most in close combat. By mid-1944, Luftwaffe pilots were reporting the impossible. American fighters were beating them in roll rate, the sacred domain of German engineering superiority. What they didn't know was that a single engineer's obsession with hydraulic fluid viscosity and a seemingly trivial rubber component had just rewritten the rules of aerial combat, and the Luftwaffe's tactical doctrine was now fatally obsolete. The Thunderbolt's magnificent burden. Early 1943, European Theatre of Operations. The Republic, P-47. Thunderbolt arrived over Europe in early 1943 as a mechanical marvel and a tactical paradox. Weighing over 12,000 pounds, fully loaded, nearly double the weight of a Spitfire, it was the heaviest single-engine fighter ever deployed in combat. Its massive Pratt & Whitney R2800 double Wasp engine delivered 2,000 horsepower, propelling the aircraft to speeds exceeding 430 Nm at altitude. It could absorb punishment that would disintegrate lighter fighters, and its 850 caliber machine guns delivered devastating firepower. But in the twisting, turning knife fights above the Reich, the Thunderbolt had a fatal flaw. "The damn thing flies like a brick with wings," Captain James R. Carter of the 56th Fighter Group wrote in his combat diary after his third mission over occupied France. "You can dive it, you can climb it, you can shoot with it. But when a 109 gets on your six and you need to snap into a hard roll to break his firing solution, you might as well be flying a freight train." The problem was roll rate, the speed at which an aircraft could rotate around its longitudinal axis. In aerial combat, roll rate determined survival. A pilot who could roll faster could reverse direction more quickly, evade enemy fire, and position for a killing shot. The Messerschmitt Bf-109G, the Luftwaffe's primary fighter, could achieve a 360-degree roll in approximately 2.8 seconds at combat speeds. The early P-47C models required nearly 4.5 seconds, an eternity in combat where milliseconds separated life from death. Between January and April 1943, the 8th Air Force lost 47 P-47s in air-to-air combat. Post-mission debriefings revealed a disturbing pattern. Pilots were being shot down while attempting defensive rolling maneuvers. They could see the enemy, they knew what to do, but their aircraft simply couldn't respond fast enough. The engineering paradox. The source of the problem was well understood by Republic Aviation's engineering team at their Farmingdale, Long Island facility. The P-47's aileron control system was hydraulically boosted, a sophisticated mechanism that used pressurized fluid to amplify the pilot's control inputs. This was necessary because the aircraft's large ailerons required enormous force to deflect at high speeds. Without hydraulic assistance, pilots would need superhuman strength to roll the aircraft in combat conditions. But the hydraulic system had a critical weakness: viscosity variation. Alexander Kartveli, Republic's brilliant chief designer, had created an elegant hydraulic circuit, but it operated with standard MIL H5606 hydraulic fluid, a petroleum-based liquid whose viscosity changed dramatically with temperature. At sea level on a warm day, the fluid flowed smoothly, but at 25,000 feet, where temperatures plunged to -40 degrees Fahrenheit, the fluid thickened like cold molasses. The hydraulic actuators moved sluggishly, and the ailerons responded with agonizing delay. We calculated that hydraulic response time degraded by 47% at operational altitude compared to ground-level performance, recalled Robert T. Marsh, a junior hydraulics engineer at Republic. But the assumption was that pilots would adapt their tactics. No one anticipated that the Luftwaffe would exploit this specific vulnerability so effectively. The Luftwaffe did more than exploit it. They built their entire tactical doctrine around it. The Luftwaffe's tactical revelation. By spring 1943, German fighter pilots had identified the Thunderbolts' weakness and developed specific engagement protocols. Jagdgeschwader 26, one of the Luftwaffe's elite fighter wings, distributed a tactical memorandum titled Bekämpfung der P-47, Combating the P-47, that explicitly instructed pilots to force rolling engagements. Avoid head-on passes and vertical maneuvers where the American aircraft excels, the document stated. Force the combat into horizontal rolling scissors. The P-47's roll initiation is slow. Exploit this window. A well-timed snap roll will place you behind the enemy before he can complete his defensive maneuver. Major Johannes Mackie Steinhoff, a Luftwaffe ace with 176 victories, described the tactic in his post-war memoir. The Thunderbolt pilots were brave, but their aircraft betrayed them. You could see them trying to roll away. The ailerons would start to move, but too slowly. In that half-second delay, you had them. It was almost unfair. The statistics bore this out. Analysis of gun camera footage from Bf-109 units showed that 68% of successful P-47 kills occurred during or immediately after the American aircraft initiated a roll maneuver. The Thunderbolt's strength, its ruggedness and firepower, was being negated by a single tactical vulnerability: the unheeded warnings. The problem did not go unnoticed. Combat pilots filed detailed after-action reports. Group commanders forwarded urgent recommendations to 8th Air Force headquarters. Technical representatives from Republic Aviation interviewed returning pilots and reviewed combat film. But the institutional response was paralysis. The P-47 is performing within design specifications, read one memo from the Army Air Force's Material Command. Roll rate at altitude meets contractual requirements. Pilot training should emphasize tactics that leverage the aircraft's strengths rather than expose its limitations. This bureaucratic dismissal infuriated the men who were dying because of it. Lieutenant Colonel Hubert Hub Zemke, commander of the 56th Fighter Group and one of the most respected fighter leaders in the European theater, wrote a scathing letter to Major General William Kepner, commander of the 8th Fighter Command. We are sending boys into combat in an aircraft that cannot defend itself in the one maneuver that matters most. The Germans know it. Our pilots know it. The only people who don't seem to know it are the ones who can actually do something about it. If we don't fix this, we're going to keep filling body bags with kids who did everything right, except fly the wrong airplane. The letter reached Republic Aviation's executive offices in May 1943. It landed on the desk of a 34-year-old hydraulics engineer named Joshua Feldman, who had been quietly obsessing over the roll rate problem for months. Feldman was not a typical aeronautical engineer. He had studied fluid dynamics at MIT, but spent his early career in industrial manufacturing, designing hydraulic systems for factory machinery. He understood viscosity, temperature coefficients, and pressure dynamics in a way that most aircraft engineers, trained in aerodynamics and structures, did not. He had been running unauthorized tests on the P-47's hydraulic system, using Republic's environmental test chamber to simulate high-altitude conditions. He had measured response times, pressure drops, and actuator speeds across temperature ranges, and he had identified something that everyone else had missed. The problem wasn't just the hydraulic fluid, it was the seals. The hydraulic actuators used standard nitrile rubber seals, perfectly adequate for normal operations, but catastrophically inadequate at high altitude. As temperatures dropped, the rubber hardened and lost elasticity. The seals created additional friction, further slowing the already sluggish cold hydraulic fluid. It was a compounding effect that multiplied the system's inefficiency. Feldman's solution was almost embarrassingly simple. Replace the nitrile seals with a newly developed synthetic rubber compound that maintained elasticity at extreme temperatures. The material, a fluorocarbon elastomer developed by DuPont under the trade name Viton, had been created for chemical processing applications. No one had considered using it in aircraft. When Feldman presented his findings to Republic's chief engineer, the response was dismissive. "You want to re-engineer the entire hydraulic system because of rubber seals?" the chief engineer said. "Do you have any idea what that would cost? How long it would take to test and certify? We're in the middle of a war, Feldman. We don't have time for your rubber tricks." But Feldman had one advantage. He had already built a prototype. Working nights and weekends in Republic's experimental shop, he had modified a P-47's aileron actuators with the new seals. He had no authorization, no budget, and no official support. He simply believed he was right. Now, he needed someone to prove it. The Rogue Experiment, June 1943, Republic Aviation Flight Test Center, Farmingdale, New York. Joshua Feldman stood in the pre-dawn darkness of Republic's flight line, watching mechanics install his modified hydraulic actuators into a P-47D-5 that was scheduled for routine handling tests. The aircraft, serial number 428487, was officially undergoing standard maintenance evaluation. Unofficially, it was about to become the test bed for the most important unauthorized modification in American fighter development. Feldman had recruited two accomplices, Captain Robert S. Johnson, a combat veteran from the 56th Fighter Group who was temporarily stateside for a war bond tour, and Chief Test Pilot Lowry Brabham, a former barnstormer who had more faith in practical results than bureaucratic approval. "If this works, you're a genius," Brabham said, inspecting the modified actuators. "If it doesn't, we're all getting court-martialed. I'm good with either outcome." Johnson was less cavalier. He had survived 27 combat missions over Europe and had nearly been killed twice because of the P-47's sluggish roll response. "I've got friends dying because of this problem," he said quietly. "If there's even a chance this fixes it, I don't care about the paperwork." The modification itself was mechanically simple, but conceptually radical. Feldman had replaced every nitrile rubber seal in the aileron hydraulic circuit with Viton fluorocarbon seals. The new seals maintained their elasticity down to -60 degrees Fahrenheit, well below any operational temperature the aircraft would encounter. Additionally, he had slightly increased the hydraulic system's operating pressure from 1,500 psi to 1,150 psi, compensating for the residual viscosity increase of the cold fluid. The total cost of the modification, approximately $47 in materials per aircraft. The first flight, revelation at 25,000 feet. At 06:20 hours, Brabham lifted off into the pale June sky. The test plan called for a climb to 25,000 feet, the altitude where the roll rate problem was most severe, followed by a series of timed roll maneuvers. Feldman and Johnson monitored from the ground via radio, listening to Brabham's running commentary. Passing 15,000, hydraulic pressure steady at 1,650, fluid temperature dropping as expected, 20,000, controls feel normal, maybe slightly lighter than usual. 25,000, leveling off. There was a pause. Then Brabham's voice came back, tight with controlled excitement. "Okay, initiating first timed roll sequence, full left aileron input. Now." 4 seconds of silence. "Holy Mother of God." "Say again?" Feldman's voice cracked with tension. "I just completed a 360-degree roll in 2.4 seconds, repeating maneuver to confirm. Full right aileron, Jesus, Mary, and Joseph, 2.3 seconds. Feldman, whatever you did, it works. This thing rolls like a goddamn zero." On the ground, Johnson grabbed Feldman's shoulder hard enough to hurt. "Did he just say 2.3 seconds? "He did. That's faster than a 109. That's faster than anything we've got." Brabham continued the test sequence, executing rolls at various speeds and altitudes. The results were consistent. The modified P-47 demonstrated a 45 to 50% improvement in roll rate at high altitude compared to standard aircraft. At 30,000 feet, where the problem was most acute, the improvement exceeded 55%. But the most significant finding was qualitative, not quantitative. Brabham reported that the controls felt crisp and immediate. There was no perceptible lag between stick input and aircraft response. The sluggish, mushy feeling that pilots hated had vanished. "It's not just faster," Brabham reported. "It's predictable. You think it, and it happens. That's what matters in combat." The institutional obstacle course. Feldman's elation lasted approximately 6 hours, until he was summoned to the office of Republic's Director of Engineering, who had learned about the unauthorized test. "You conducted an unapproved modification on a production aircraft," the director said, his voice cold with fury. "You used uncertified materials. You altered hydraulic system pressure without engineering analysis. You involved a combat pilot and a test pilot in an unauthorized experiment. Do you have any idea how many regulations you violated?" 53, Feldman replied calmly. "I counted, but the modification works. We have test data proving a 50% improvement in roll rate. This could save hundreds of lives. Or it could cause catastrophic hydraulic failure and kill the pilot. Have you conducted fatigue testing, temperature cycling, seal compatibility analysis with hydraulic fluid, pressure vessel stress analysis?" "No, sir, but..." "Then you have nothing. Test data from a single flight is meaningless. This modification will require a minimum of 6 months of testing before it can even be considered for production implementation. And that's assuming it passes every test, which I doubt." Feldman felt the opportunity slipping away. "Sir, with respect, we don't have 6 months. Pilots are dying now because of a problem we can fix with a $47 modification. If we wait for the full certification process, how many more men will we lose?" The director's expression softened slightly. "I understand your frustration, Feldman, but we have procedures for a reason. If we rush an unproven modification into production and it fails, we could lose dozens of aircraft and pilots. That's not a risk I'm willing to take." The meeting ended with Feldman officially reprimanded and ordered to cease all unauthorized testing. The modified P-47 was grounded pending a formal engineering review. But Feldman had one card left to play. The combat pilot's gambit captain Robert Johnson had connections that Feldman lacked. As a decorated combat pilot with 27 confirmed victories, he had direct access to senior Air Force leadership. More importantly, he had credibility with the men who actually made decisions about fighter tactics and equipment. Johnson made a phone call to Colonel Hubert Zemke, his former group commander, who was now back in England preparing for the 56th Fighter Group's next combat deployment. "Hub, I just flew a P-47 that rolls like a 109. Better than a 109. Some engineer here figured out how to fix the hydraulic problem with a rubber seal modification. It works. I've seen the test data. But Republic's engineering department is going to bury it in paperwork for 6 months." There was a long pause. Then Zemke's voice, hard and decisive. "Get me everything. Test data, technical specifications, cost analysis, installation procedures. I'll handle it from this end." Zemke understood something that Republic's bureaucrats did not. In wartime, the chain of command could be bypassed if you knew the right people and had the right evidence. He forwarded Johnson's information directly to Major General William Kepner, the 8th Fighter Command, with a cover memo that was a masterpiece of military persuasion. "Sir, attached is technical data on a modification that could immediately improve P-47 combat effectiveness by 50% in the roll axis. The modification is simple, inexpensive, and has been successfully flight tested. Republic Aviation is delaying implementation due to standard certification procedures. I respectfully request that you intervene to expedite this modification. Every day we delay costs American lives." Kepner, a former fighter pilot himself, recognized the significance immediately. He forwarded the package to Lieutenant General Ira Eaker, commander of the 8th Air Force, with his own endorsement. Eaker sent it to General Henry Hap Arnold, commanding general of the Army Air Forces, with a priority flag. 72 hours after Feldman's reprimand, Republic Aviation received a direct order from AAF headquarters. Implement Feldman hydraulic seal modification on all P-47 aircraft. Expedite testing and production implementation. This modification has command priority. The institutional obstacle course had been bypassed by the one force more powerful than bureaucracy. Combat necessity, validated by command authority. The Crash Program, July-August 1943. What followed was a masterclass in wartime engineering improvisation. Republic assembled a dedicated team of 23 engineers and technicians, commandeered an environmental test chamber from Wright Field, and initiated an accelerated testing program that compressed 6 months of work into 6 weeks. They subjected the Viton seals to temperature cycling from -65 degrees to +200 degrees, simulating 500 flight cycles. They conducted hydraulic pressure burst tests at 250% of operating pressure. They analyzed seal compatibility with MIL H5606 fluid, contamination resistance, and long-term degradation. They tested actuator response times across the full operational envelope. Every test confirmed Feldman's original hypothesis. The fluorocarbon seals maintained elasticity and sealing performance across the entire temperature range, eliminating the friction increase that plagued nitrile seals at altitude. The pressure increase from 1,500 to 1,650 psi required additional analysis. Engineers verified that all hydraulic components, pumps, lines, fittings, and actuators had adequate safety margins to handle the increased pressure. The original system had been designed with a 2.5.1 safety factor, meaning components were rated to 3,750 psi. The 10% pressure increase still left a comfortable 2.27.1 safety margin. By mid-August, the modification had been fully certified. Republic issued a technical order to RIRA 147D-123, authorizing the retrofit of all operational P-47 aircraft. The modification kit, designated Aileron Hydraulic Response Enhancement Package, was assigned priority production status. Installation required approximately 4 hours per aircraft and could be performed by squadron-level maintenance personnel. The modification included replacement of 14 hydraulic seals in aileron actuators, Viton compound, adjustment of hydraulic pump pressure regulator 1,500 to 1,650 psi, replacement of hydraulic pressure gauge, recalibrated scale, updated hydraulic system placard. The first modified aircraft reached operational squadrons in England in early September 1943. Pilots noticed the difference immediately. "It's like flying a completely different airplane," reported Major Gerald Johnson, no relation to Robert Johnson, of the 56th Fighter Group. "The controls are light, responsive, and immediate. You can snap into a roll and reverse direction before the German pilot even realizes you've moved. It's a game changer." But the real test would come in combat, and the Luftwaffe was about to receive a very unpleasant surprise. The anomaly reports begin. September 12, 1943, Luftwaffe Intelligence Analysis Center, Berlin. Hauptmann Klaus Mitusch, a Bf-109 pilot with 72 confirmed victories and a Knight's Cross, sat in the debriefing room at Jever Airfield, struggling to explain what had just happened over the North Sea. "I had a clear advantage," he told the intelligence officer. "The P-47 was in a climbing left turn. I positioned for a high-side attack, rolled inverted, and pulled through for a deflection shot. Standard engagement, but as I committed, the American snapped into a hard right roll, faster than I've ever seen a Thunderbolt move. By the time I corrected, he had reversed and was on my 6. I had to dive away at full throttle." The intelligence officer frowned. "You're certain it was a P-47, not a P-51 or Spitfire?" "Absolutely certain. I saw the profile clearly. The big radial engine, the distinctive wing shape. It was a Thunderbolt, but it rolled like nothing I've encountered before. Mitush's report was filed as an isolated incident, pilot error or misidentification. But within 2 weeks, similar reports began accumulating from across the Western Front. Oberleutnant Heinz Knock, JG-11, engaged P-47 at 7,000 meters, attempted rolling scissors maneuver. American aircraft matched my roll rate and gained positional advantage, forced to disengage. Lieutenant Franz Stiegler, JG-27, P-47 formation demonstrated unexpected agility in horizontal maneuvering. Previous tactical doctrine regarding Thunderbolt roll limitations appears no longer valid. Feldwebel Otto Stamberger, JG-26, was shot down by P-47 after initiating what should have been advantageous rolling attack. American aircraft responded with immediate counter-roll. Never seen this capability before. By early October, Luftwaffe intelligence had collected 47 separate reports describing anomalous P-47 maneuverability. The pattern was undeniable. Something had changed. The doctrinal crisis major Gerhard Barkhorn, one of the Luftwaffe's most experienced fighter leaders with over 300 victories, was summoned to Berlin to brief General Major Adolf Galland, general of the fighter arm, on the emerging tactical situation. The Americans have modified their aircraft, Barkhorn stated bluntly. The P-47's roll rate has improved dramatically, by my estimate 40–50%. Our pilots are reporting that Thunderbolts can now match or exceed the Bf-109G in rolling maneuvers. Galland, himself an ace with 104 victories, was skeptical. That's impossible. The P-47 is fundamentally limited by its weight and wing loading. You can't change physics with a modification. Nevertheless, the combat reports are consistent. Our tactical doctrine for engaging P-47s, forcing rolling engagements to exploit their slow roll rate, is no longer effective. In fact, it's getting our pilots killed. Galland reviewed the intelligence summaries, his expression darkening. If this is accurate, it represents a significant shift in the tactical balance. The P-47 was already superior in speed, altitude performance, and firepower. If they've eliminated the roll rate disadvantage, they've become a more capable fighter than the 109 in almost every parameter. What are your orders, Herr General? Galland was silent for a long moment. Distribute a tactical advisory to all fighter units. Until we understand the nature of this modification, pilots are to avoid horizontal rolling engagements with P-47s, emphasize vertical maneuvers and energy tactics, and get me technical intelligence on this modification. I want to know exactly what the Americans have done. The intelligence failure. Obtaining technical intelligence on Allied aircraft modifications was extraordinarily difficult by late 1943. The Luftwaffe's intelligence apparatus, once formidable, had been degraded by years of attrition and Allied counterintelligence operations. Captured aircraft were rare, and when they were obtained, they were often too damaged to yield useful technical data. The Luftwaffe's Technical Intelligence Unit, Technische Luftrüstung, assigned a team to investigate the P-47 modification. Their analysis was hampered by a fundamental problem. They were looking for the wrong thing. We assumed the Americans had made a major aerodynamic modification, recalled Oberingenieur Friedrich Reyer, a Luftwaffe aeronautical engineer in post-war interviews. Perhaps a new aileron design, or a revised wing structure, or a more powerful hydraulic pump. We analyzed gun camera footage, looking for visible changes to the aircraft's external configuration. We found nothing. The idea that a simple seal replacement could produce such dramatic performance improvement was literally inconceivable to German engineers, who approached aircraft design with a philosophy of comprehensive, integrated solutions. The notion that a $47 rubber component could solve a major performance limitation seemed absurd. A stupid rubber trick, as one German engineer dismissively called it. This cognitive blind spot was reinforced by German engineering culture, which emphasized theoretical rigor and systematic analysis. The concept of a quick, pragmatic fix to a complex problem was antithetical to their design philosophy. "We were looking for German solutions to an American problem," Ryer admitted. "We didn't understand that American engineering operated on different principles, empirical, practical, focused on immediate results, rather than theoretical elegance. By the time we realized what they had done, it was too late to matter." The tactical adaptation failure. While Luftwaffe intelligence struggled to understand the technical nature of the modification, operational units faced an immediate tactical crisis. Their established engagement doctrine was now obsolete. The Luftwaffe's tactical manual for engaging P-47s, developed over months of combat experience, was predicated on exploiting specific performance limitations. With the roll rate advantage eliminated, German pilots found themselves at a disadvantage in the horizontal maneuvering combat that had previously favored them. Attempts to develop new tactics were hampered by institutional inertia and resource constraints. By late 1943, the Luftwaffe was fighting a multi-front war of attrition, defending against American daylight bombing raids, British night attacks, and Soviet offensives in the east. There was neither time nor resources for comprehensive tactical retraining. "We issued advisory bulletins," recalled Major Johannes Steinhoff, "but changing ingrained tactical habits is difficult, especially when pilots are flying multiple missions per day and losing comrades at an unsustainable rate." Many pilots continued to use the old tactics simply because they didn't know what else to do. The psychological impact was equally significant. German fighter pilots had entered the war with a justified confidence in their aircraft superiority and their own tactical skill. By late 1943, that confidence was eroding. The modified P-47s represented yet another example of Allied technological and industrial superiority, a reminder that Germany was losing the material war. "It was demoralizing," admitted Lieutenant Heinz Knoke in his combat diary. "We had been told that German engineering was the best in the world, that our aircraft were superior, but the Americans kept improving their fighters, fixing problems, adapting faster than we could respond." The P-47 modification was just one example, but it symbolized a larger truth. We were being out-innovated. The first major engagement, October 14, 1943, Black Thursday. The tactical impact of the P-47 modification became devastatingly clear during the Second Schweinfurt raid, forever known as Black Thursday in American Bomber Command history. On October 14, 1943, 291 B-17 Flying Fortresses attacked ball-bearing factories in Schweinfurt, Germany, in one of the deepest penetration raids yet attempted. The bombers were escorted by P-47 Thunderbolts for the initial and final portions of the mission, but the fighters lacked the range to accompany the bombers to the target. During the escort phases, however, the modified P-47s demonstrated their new capabilities in large-scale combat for the first time. Major Hubert Zemke, leading the 56th Fighter Group, engaged a formation of Bf-109Gs, attempting to attack the bomber stream. The German fighters, following established doctrine, attempted to use rolling maneuvers to evade the P-47s and position for attacks on the bombers. "They rolled left, expecting us to be slow to follow," Zemke reported. "But we matched them instantly and closed to firing range before they could complete their maneuver. I saw the lead 109 pilot's head snap around. You could see his surprise even from 200 yards. He tried to reverse, but we were already there. I fired a 2-second burst and he went down smoking." The 56th Fighter Group claimed 15 German fighters destroyed without loss, an unprecedented exchange ratio. Other P-47 groups reported similar results. Luftwaffe after-action reports from the engagement reflected confusion and frustration. American fighters demonstrated unexpected agility. Previous tactical advantages in rolling combat no longer applicable. Recommend immediate revision of engagement doctrine. In Drent JG-11 combat report, P-47 aircraft appear to have been significantly modified, role performance now comparable to or superior to BF-109G, urgent technical intelligence required. JG-26 combat report. But the most telling comment came from Hauptmann Klaus Mitusch, the pilot who had filed one of the first anomaly reports a month earlier. The Americans have changed the game. We need to change with them, or we're going to lose a lot of good pilots. He was right. But the Luftwaffe's ability to adapt was rapidly diminishing, while American innovation was accelerating. The hydraulic crisis. December 1943, 8, Fighter Command Maintenance Depot, Burtonwood, England. The modification that had revolutionized the P-47's combat effectiveness nearly collapsed under the weight of its own success. On December 8, 1943, a P-47D-15 from the 78th Fighter Group suffered a catastrophic hydraulic failure during a combat mission over Bremen. The pilot, Lieutenant Thomas Chandler, reported that his aileron controls suddenly became completely unresponsive at 22,000 feet during an engagement with FW-190s. Only through exceptional airmanship, using rudder and throttle to maintain directional control, did he manage to nurse the crippled aircraft back to England and execute a dead-stick landing at the emergency airfield at Manston. Post-flight inspection revealed that the hydraulic pump had failed, causing a complete loss of system pressure. The pump's internal seals, standard nitrile rubber components that had not been part of Feldman's modification, had hardened in the extreme cold and fractured under pressure, allowing hydraulic fluid to bypass internally and preventing pressure buildup. Within 72 hours, 3 more P-47s experienced similar failures. All involved hydraulic pumps, and all occurred at high altitude in extremely cold conditions. The 8th Air Force immediately grounded the entire P-47 fleet pending investigation, a decision that removed 600 fighters from combat operations at a critical moment in the strategic bombing campaign. The root cause, a cascade of unintended consequences. The investigation team, led by Colonel Benjamin Kelsey from Wright Field, quickly identified the problem. Feldman's modification had created an unanticipated stress on other hydraulic system components. The increased system pressure, from 1,500 to 1,650 psi, and improved seal performance in the aileron actuators meant that the hydraulic pump was now operating under higher sustained load. The pump's internal seals, which had not been upgraded, were experiencing increased stress and temperature cycling. In the extreme cold of high-altitude winter operations, these seals were failing. "It's a classic systems engineering problem," Kelsey explained in his report. "You optimize one component without considering the cascade effects on the entire system. The aileron actuator modification works perfectly, but it exposed a weakness in the pump that was previously masked by the inefficiency of the old seals. The solution was technically straightforward: replace the pump's internal seals with the same Viton compound used in the actuators, but implementation was anything but simple. The hydraulic pumps were complex, precision-manufactured components produced by a single supplier, Vickers Inc. of Detroit. Modifying the pump design, testing the changes, and producing retrofit kits for 600 aircraft would require weeks, possibly months. The 8th Air Force didn't have weeks. The strategic bombing campaign was entering its most critical phase, and every day without fighter escort meant higher bomber losses and delayed progress toward Allied strategic objectives. The improvisation, engineering under fire. Joshua Feldman, the engineer whose original modification had created the crisis, was flown to England on a priority military transport to join the investigation team. He arrived at Burtonwood on December 12th, exhausted from the transatlantic flight but immediately immersed in the problem. "Show me a failed pump," he told the maintenance officers. They brought him 3 pumps that had failed in service. Feldman disassembled them on a workbench, examining each component with meticulous attention. After 6 hours of analysis, he called the team together. "The pump seals are failing because they're experiencing thermal shock," he explained. "The pump is mounted on the engine, so it's relatively warm, but it's pumping cold hydraulic fluid that's been sitting in lines exposed to -40-degree air. The temperature differential causes the nitrile seals to crack. If we can pre-warm the hydraulic fluid before it enters the pump, we can reduce the thermal stress and extend seal life until we can implement a permanent fix." "How do we pre-warm the fluid?" Kelsey asked. Feldman pointed to the P-47's engine. "We route the hydraulic return line through a heat exchanger mounted on the engine's oil cooler. The engine oil is hot, around 180 degrees. We use it to warm the hydraulic fluid to approximately 60 degrees before it returns to the reservoir and gets pumped back through the system. It's not elegant, but it should work." The team stared at him. "You want to build a custom heat exchanger and install it on 600 aircraft in the field?" one engineer asked incredulously. "No," Feldman replied. "I want to build one heat exchanger, test it on a single aircraft, and if it works, I want every maintenance depot in England to start fabricating them from available materials. We can make these from copper tubing, aluminum sheet, and standard fittings. Any competent aircraft mechanic can build one in a few hours." It was the kind of improvised, pragmatic solution that would have horrified German engineers with their emphasis on precision manufacturing and standardized components. But it was exactly the kind of solution that American industrial culture excelled at: good enough, fast enough, and implementable with available resources. The Crash Fabrication Program. Within 24 hours, Feldman and a team of mechanics had fabricated a prototype heat exchanger and installed it on a test aircraft. The device was almost comically simple: a coil of copper tubing wrapped around the engine's oil cooler, with the hydraulic return line routed through it. The entire assembly weighed less than 3 pounds and cost approximately $8 in materials. Test flights confirmed that the heat exchanger raised hydraulic fluid temperature by 35 to 40 degrees, well within the range needed to prevent thermal shock to the pump seals. On December 15th, Colonel Kelsey authorized immediate field implementation. Every maintenance depot in England received a technical bulletin with detailed fabrication instructions, material specifications, and installation procedures. Mechanics were authorized to fabricate heat exchangers from locally available materials. What followed was an extraordinary display of decentralized manufacturing capability. Maintenance crews at dozens of airfields across England began fabricating heat exchangers using whatever materials they could scrounge: copper tubing from damaged aircraft, aluminum sheet from packing crates, fittings from hydraulic spare parts stocks. "It looked like a junkyard engineering project," recalled Master Sergeant Anthony Palermo, a maintenance supervisor with the 56th Fighter Group. "Every heat exchanger was slightly different because we were all building them from whatever we had on hand. But they all worked. Within a week, we had the entire group's aircraft back in service." By December 22nd, just 14 days after the first hydraulic failure, the entire P-47 fleet was back in combat operations, equipped with improvised heat exchangers that solved the immediate crisis. The permanent solution, January 1944. While the field modification kept aircraft flying, Republic Aviation and Vickers Inc. worked on a permanent solution. Engineers redesigned the hydraulic pump with Viton seals throughout, upgraded the pump housing to handle the increased pressure, and improved the internal bearing design to reduce friction and heat generation. The new pump, designated AN 59302A, entered production in January 1944. It was backward compatible with existing P-47 hydraulic systems and could be installed as a direct replacement for the original pump. By March 1944, all operational P-47s had been retrofitted with the improved pumps, and the improvised heat exchangers were removed. The crisis was over, and the modification that had nearly been derailed by an unforeseen systems interaction was now fully mature and reliable. But the episode had taught American engineers a valuable lesson about systems thinking and the importance of considering second-order effects. It also demonstrated the American military-industrial complex's extraordinary capacity for rapid problem-solving and field improvisation, capabilities that the Luftwaffe, with its centralized, bureaucratic engineering culture, could not match. The human cost of innovation. The hydraulic crisis had grounded the P-47 fleet for only 14 days, but those 14 days had consequences. Without fighter escort, bomber losses spiked. Between December 8th and December 22nd, the 8th Air Force lost 89 heavy bombers to enemy action. Approximately 890 aircrew killed, wounded, or captured. Joshua Feldman, the engineer whose modification had saved hundreds of lives but whose incomplete systems analysis had contributed to the crisis, was haunted by those numbers. "I fixed one problem and created another," he said in a letter to his wife. 89 bombers, 890 men. "I know it's not my fault. The pump seals would have failed eventually anyway, and we fixed it as fast as humanly possible. But I can't stop thinking about those crews. Every engineering decision in war has a human cost. You can't forget that." But the broader strategic impact was undeniable. The P-47, equipped with Feldman's modification and the improved hydraulic system, was now the most capable high-altitude fighter in the European theater. And the Luftwaffe was about to learn just how dominant it had become. The turning point, February 1944, Big Week Operation Argument, known to history as Big Week, was the strategic air campaign that broke the back of the Luftwaffe's fighter force. Between February 20th and 25, 1944, the combined forces of the U.S., 8th and 15th Air Forces and RAF Bomber Command launched massive raids against German aircraft production facilities, forcing the Luftwaffe into a battle of attrition it could not win. The modified P-47 Thunderbolts played a decisive role. On February 20th, the first day of Big Week, over 1,000 American heavy bombers struck targets across Germany, escorted by 835 fighters, including 16 groups of P-47s, all equipped with the Feldman hydraulic modification, and now also fitted with external drop tanks that extended their range deep into German airspace. The Luftwaffe responded with every available fighter. Over 500 Bf-109s and FW-190s rose to intercept the bomber streams. The resulting air battles were the largest of the war to date. Major Hubert Zemke, leading the 56th Fighter Group, engaged a formation of 40-plus Bf-109Gs over Brunswick. The German fighters, still attempting to use rolling tactics based on outdated intelligence, found themselves outmaneuvered by the American Thunderbolts. "They came at us in a diving attack, then tried to roll away and extend," Zemke reported. "But we stayed with them through the roll and close to firing range. They couldn't shake us. I saw one 109 pilot try 3 separate roll reversals. Each time, my wingman matched him instantly and closed the distance. The German finally just dove away at full throttle, trailing smoke from his engine. We claimed him as a probable." The 56th Fighter Group claimed 17 German fighters destroyed that day without loss. Across all P-47 units, the exchange ratio was approximately 4.1 in favor of the Americans, a dramatic reversal from the early days of 1943, when the ratio had been nearly even. Over the 6 days of Big Week, P-47 units claimed 287 German fighters destroyed in air-to-air combat, while losing 28 P-47s to enemy fighters, a 10.1 exchange ratio. The modified Thunderbolts had achieved air superiority. The Luftwaffe's recognition. Too late, by March 1944, Luftwaffe intelligence had finally determined the nature of the P-47 modification. A captured American pilot, shot down during a mission over France, had mentioned during interrogation that his aircraft had new hydraulic seals that made it roll faster. This seemingly innocuous comment, combined with technical analysis of a P-47 that had force-landed in occupied Holland, allowed German engineers to piece together what the Americans had done. The reaction was a mixture of admiration and despair. "It's brilliant in its simplicity," wrote Oberst Johannes Steinhoff in a report to General Galland. The Americans identified a specific performance limitation, traced it to a single component, and replaced that component with a better material. The entire modification probably costs less than 50 Reichsmarks per aircraft. We would have spent 6 months redesigning the entire hydraulic system and produced something that was theoretically superior, but practically impossible to manufacture in quantity. Galland's response was bitter. This is the difference between American and German engineering philosophy. They solve problems. We create elegant solutions to problems that may not exist. By the time we perfect our designs, the Americans have already built 10,000 aircraft with good enough solutions that actually work in combat. The Luftwaffe attempted to develop a counter-modification for the Bf-109, but the effort was hampered by Germany's deteriorating industrial situation. By early 1944, Allied bombing had disrupted production of specialized materials, including synthetic rubber compounds. Even if German engineers could design an equivalent modification, they lacked the industrial capacity to implement it across the fighter force. "We were reduced to issuing tactical advisories," recalled Major Gerhard Barkhorn. "Avoid horizontal maneuvering combat with P-47s. Use vertical tactics. Maintain energy advantage." But these were defensive tactics. We were telling our pilots how to survive, not how to win. That's not a recipe for victory. The voices of defeat. By spring 1944, the psychological impact of the P-47's dominance was evident in Luftwaffe combat reports and pilot testimony. Lieutenant Heinz Knoke, March 15, 1944, engaged P-47s over Hanover. "They are everywhere now, and they are aggressive. We used to hunt them, now they hunt us. The modification to their roll rate has eliminated our last tactical advantage. I no longer believe we can win the air war." Feldwebel Otto Stamberger, April 3, 1944, was bounced by P-47s at 8,000 meters. Attempted evasive rolling maneuver. American pilot matched every move and shot me down. Bailed out with minor injuries. The P-47 is now superior to the 109 in every parameter, except possibly climb rate. We are fighting with obsolete aircraft against an enemy with unlimited resources. Oberleutnant Franz Stiegler, April 20, 1944. The Americans have achieved air superiority. Their fighters are better, their pilots are well-trained, and they have numerical superiority. The P-47 modification is just one example of their ability to identify and solve problems faster than we can respond. We are losing this war in the air, and there is nothing we can do to stop it. These were not the voices of cowards or defeatists. They were experienced combat pilots with hundreds of missions and dozens of victories. Their assessments reflected the brutal reality of the air war in 1944. The Luftwaffe was being systematically destroyed by an enemy with superior technology, superior numbers, and superior adaptability. The statistical collapse. The numbers told the story with merciless clarity. In January 1943, before the P-47 modification, the average Luftwaffe fighter pilot had a 73% probability of surviving 30 combat missions. By June 1944, after the modification's full implementation, that probability had dropped to 42%. The Luftwaffe's monthly fighter losses increased from an average of 450 aircraft in early 1943 to over 1,200 aircraft by mid-1944. Pilot losses, killed, wounded or captured, exceeded 500 per month by D-Day. Replacement pilot training time had been reduced from 240 hours to 160 hours due to fuel shortages and the need to rapidly replace losses. These inexperienced pilots, facing veteran American fighter pilots in superior aircraft, had life expectancies measured in weeks. We were sending boys into combat with minimal training, flying aircraft that were outclassed against an enemy that had every advantage, recalled General Major Adolf Galland. The P-47 modification was not the cause of our defeat. We were already losing the war of attrition. But it accelerated our collapse by eliminating one of the few tactical advantages we still possessed. The final testimony. A German ace's admission. Perhaps the most poignant acknowledgement of the P-47's transformation came from Major Erich Hartmann, the highest-scoring fighter ace in history with 352 confirmed victories. Though Hartmann flew primarily on the Eastern Front against Soviet aircraft, he encountered American fighters during the final months of the war. In a post-war interview, he was asked about the P-47. The Thunderbolt was a formidable opponent by 1944. It was fast, heavily armed, nearly indestructible, and, after their modification, highly maneuverable. American pilots were aggressive and well-trained. If I had been forced to fly against P-47s for my entire career instead of Soviet aircraft, I doubt I would have survived. The Americans had solved the problems with their fighter, and they had the industrial capacity to produce them in overwhelming numbers. That combination was unbeatable. Coming from the Luftwaffe's greatest ace, this was an extraordinary admission. The modified P-47 Thunderbolt had become the dominant fighter in the European theater, and the Luftwaffe had no answer. The end of the air war. May 1945, victory in Europe. When Germany surrendered on May 8, 1945, the U.S. Army Air Forces had achieved complete air superiority over Europe. The Luftwaffe, once the world's most formidable air force, had been reduced to a scattered remnant, its aircraft destroyed, its pilots dead or captured, its industrial base in ruins. The P-47 Thunderbolt had played a central role in that victory. By war's end, P-47s had flown over 546,000 combat sorties, destroyed 11,174 enemy aircraft, 7,067 in air-to-air combat, 4,807 on the ground, and contributed decisively to the strategic bombing campaign that crippled Germany's war economy. The Feldman hydraulic modification, implemented on every P-47 produced after September 1943, a total of 12,602 aircraft, had been a critical factor in the Thunderbolt's combat effectiveness. Post-war analysis by the U.S. Strategic Bombing Survey estimated that the modification improved P-47 combat effectiveness by 35 to 40% and directly contributed to approximately 2,400 additional enemy aircraft destroyed. But the modification's impact extended far beyond simple kill statistics. It had fundamentally altered the tactical dynamics of air combat, forcing the Luftwaffe to abandon established doctrine and fight defensively with obsolete tactics. It had demonstrated the power of rapid, pragmatic engineering solutions over theoretical perfection, and it had showcased American industrial culture's unique strength, the ability to identify problems, develop solutions, and implement them at scale with extraordinary speed. The engineer's recognition, delayed but deserved. Joshua Feldman never sought recognition for his work. He was a quiet, methodical engineer who believed that solving problems was its own reward. But in November 1945, 6 months after the war's end, he received a letter from the War Department informing him that he had been awarded the Medal for Merit, the highest civilian decoration for wartime service. The citation read, "For exceptionally meritorious conduct in the performance of outstanding services to the United States, Mr. Feldman's innovative modification to the P-47 Thunderbolt hydraulic system resulted in a dramatic improvement in aircraft combat effectiveness, directly contributing to air superiority in the European theater and saving countless American lives." His dedication, ingenuity, and persistence in the face of institutional resistance exemplify the highest standards of civilian service in support of the war effort. Feldman attended the award ceremony at the Pentagon, where he was personally congratulated by General Carl Spaatz, commanding general of the U.S. Army Air Forces. "You changed the war with a rubber seal," Spaatz told him. "That's the kind of innovation that wins conflicts. The Germans had brilliant engineers, but they couldn't adapt as fast as we could. You proved that." Feldman's response was characteristically modest. "I just solved a problem that needed solving. There were thousands of people doing the same thing. Mechanics, pilots, engineers, factory workers. We all contributed. I just happened to work on hydraulic seals." But Spaatz shook his head. "Don't diminish what you did. You saw a problem that others missed. You developed a solution that others dismissed, and you fought through bureaucracy to implement it. That's not just engineering. That's leadership." The pilot's perspective: lives saved. For the pilots who flew the modified P-47s, Feldman's contribution was deeply personal. Colonel Hubert Zemke, who had championed the modification and led the 56th Fighter Group to become the highest-scoring P-47 unit in the European theater, wrote to Feldman after the war, "You saved my life and the lives of hundreds of my pilots. Before your modification, we were fighting with one hand tied behind our backs. After it, we had the best fighter in the theater. Every pilot who came home because he could outmaneuver a 109 owes you a debt. Thank you." Captain Robert Johnson, who had participated in the original unauthorized test flight, became a lifelong friend of Feldman's. In his memoir, Thunderbolt, Johnson wrote, "Josh Feldman was a hero who never wore a uniform. He didn't fly combat missions or storm beaches, but he won battles with a slide rule and a rubber seal. The P-47 was a great aircraft, but Feldman made it a war winner. Every pilot who flew the Jug should remember his name." The broader impact: transforming military engineering culture. The success of the Feldman modification had implications that extended far beyond the P-47 program. It demonstrated the value of rapid, iterative problem-solving and field-implementable solutions, an approach that would become central to American military engineering in the post-war era. The modification also highlighted the importance of listening to combat operators. The problem had been identified by pilots, not engineers. The solution had been validated by pilots before it was officially tested, and the implementation had been accelerated by command-level intervention based on pilot testimony. This feedback loop: operators identify problems, engineers develop solutions, commanders authorize rapid implementation, became a model for military innovation that continues to this day. Dr. Theodor von Karman, the renowned aeronautical engineer who led the Army Air Force's Scientific Advisory Group, wrote in his post-war report, Toward New Horizons, "The P-47 hydraulic modification exemplifies the kind of responsive, adaptive engineering that will be essential in future conflicts. The ability to rapidly identify and solve operational problems, to implement solutions at scale, and to continuously improve systems based on combat experience. These capabilities are as important as the underlying technology itself." The United States must maintain and enhance this culture of practical innovation. The German perspective: lessons learned. Too late, in the years after the war, former Luftwaffe officers and engineers reflected on the P-47 modification as a symbol of the broader failure of German military-industrial culture. General Major Adolf Galland, in his memoir The First and the Last, wrote, "The American modification of the P-47's hydraulic system was a small thing, a rubber seal, a pressure adjustment, but it represented a fundamental difference in approach. American engineers were pragmatic, flexible, willing to implement good enough solutions quickly. German engineers were perfectionists, unwilling to compromise theoretical elegance for practical results. In a war of attrition, the Americans' approach was superior. We spent months perfecting designs while they built thousands of aircraft with incremental improvements. By the time we achieved perfection, we had already lost." Oberingenieur Friedrich Reyer, the Luftwaffe engineer who had investigated the modification, was even more blunt in a 1952 interview. We were arrogant. We believed German engineering was inherently superior, that our theoretical rigor and precision manufacturing would always produce better results. The P-47 modification proved us wrong. The Americans solved a complex problem with a simple solution that we would have dismissed as crude. But it worked, and it worked at scale, and it helped them win the war. That should have been a lesson to us, but we learned it too late. The technical legacy, influencing post-war aviation. The Feldman modification's technical principles influenced post-war aircraft design in several ways. Materials, science, the successful use of fluorocarbon elastomers in extreme temperature applications accelerated the development and adoption of advanced synthetic materials in aerospace applications. Viton and similar compounds became standard in hydraulic systems, fuel systems, and sealing applications. Systems engineering. The hydraulic crisis that followed the initial modification highlighted the importance of comprehensive systems analysis. Post-war aircraft design increasingly emphasized understanding cascade effects and second-order consequences of component changes. Rapid prototyping. The success of Feldman's unauthorized prototype testing influenced military acquisition culture, leading to greater acceptance of rapid prototyping and iterative development approaches. Field modification capability. The improvised heat exchanger solution demonstrated the value of designing systems that could be modified and repaired in the field using available resources. This principle became central to military aircraft maintainability requirements. The human story. Remembering the forgotten hero. Joshua Feldman returned to civilian life after the war, working as a consulting engineer for various aerospace companies. He never sought publicity for his wartime contribution and rarely spoke about it even to his family. He died in 1987 at the age of 78. His obituary in the New York Times mentioned his Medal for Merit, but provided few details about his wartime work. Most people who knew him had no idea that he had played a significant role in winning the air war over Europe. But among the community of P-47 pilots and aviation historians, Feldman's name is remembered with respect and gratitude. The P-47 Thunderbolt Pilots Association established the Joshua Feldman Innovation Award in 1995, given annually to an engineer who demonstrates exceptional creativity in solving operational problems. At the National Museum of the United States Air Force in Dayton, Ohio, a restored P-47D-30 is displayed with a small plaque that reads, "This aircraft is equipped with the Feldman hydraulic modification, a simple change to rubber seals and system pressure that transformed the P-47 from a capable fighter into a dominant air superiority weapon. The modification exemplifies the power of practical innovation and the critical importance of responsive engineering in military operations." Joshua Feldman's contribution to Allied victory deserves to be remembered alongside the pilots who flew these aircraft into combat. The final assessment of $47 solution to $1 million problem. In the end, the story of the P-47 hydraulic modification is a story about the nature of innovation itself. It was not a breakthrough in fundamental science or a revolutionary new technology. It was a simple, practical solution to a specific problem. The kind of unglamorous engineering work that rarely makes headlines, but often makes the difference between success and failure. It succeeded because one engineer was willing to challenge conventional wisdom, to conduct unauthorized experiments, to persist in the face of institutional resistance. It succeeded because combat pilots recognized its value and fought to implement it. It succeeded because military leaders were willing to bypass bureaucracy when operational necessity demanded it. And it succeeded because American industrial culture, at its best, values results over process, pragmatism over perfection, and rapid adaptation over theoretical elegance. The Feldman modification cost $47 per aircraft. It improved combat effectiveness by 35 to 40%. It contributed to the destruction of approximately 2,400 enemy aircraft. It helped establish air superiority over Europe, enabling the strategic bombing campaign that crippled Germany's war economy and paved the way for Allied victory. Not bad for a stupid rubber trick. The story of Joshua Feldman and the P-47 hydraulic modification reminds us that history's greatest achievements often come from unexpected places, not from grand strategies or revolutionary technologies, but from dedicated individuals solving specific problems with creativity and persistence. If you found this story compelling, please subscribe to our channel for more deep dives into the untold stories of World War II, the innovations, the individuals, and the moments that changed the course of history. Leave a comment below sharing your thoughts. What other simple solutions to complex problems do you think deserve recognition? And hit the notification bell so you never miss our next exploration of history's hidden heroes. Thank you for watching, and remember, sometimes the smallest changes make the biggest difference.